All right, so here's the answer key to the test review. So the first one says to solve the nonlinear systems by substitution. So what I'm going to go ahead and do here is let's go ahead and take, it doesn't really matter what we substitute. I'm going to substitute this x squared plus 1 because it says y equals, and for this y. And what that's going to do for me is I can write x squared plus 1 is equal to 3x plus 5. Now at this point right here, I need to set it equal to 0 since it's a quadratic function so that I can solve it. So what we're going to do is we're going to subtract the 3x and subtract the 5, and I'm going to do that at the same time. And just make sure you are combining correctly with the like terms. So in this case here we have x squared minus 3x, and then 1 minus 5 is negative 4, is going to be set equal to 0. Now from here what I can do is I can factor this. So I'm going to do this work right here. So my b value is negative 3, that goes on the top. A value is 1, so I'm dividing by 1, and then I multiply 1 times negative 4, so a times c is negative 4. And my two factors that add to negative 3 but multiply to negative 4 are going to be negative 4 and positive 1. So my factors are going to be x minus 4, x plus 1 is set equal to 0. Then you're going to set each factor equal to 0. So x minus 4 equals to 0, and x plus 1 is equal to 0. And then when you solve it here, I know I'm going to add 4, so x is equal to 4, and this one I'm going to subtract 1, so x is equal to negative 1. All right, now, so when we are solving a nonlinear system, it's not just x equals, we have to get the ordered pair. So in this case, we're going to have to figure out our corresponding y values for each one. So I'll do these right here. Let me put a line here so you know my work. X is equal to 4, and x is equal to negative 1. All right, so for the first one, I'm going to put it into this linear function here. So y equals 3 times 4 plus 5, which is 12 plus 5, which is 17. So my ordered pair for this one is x comma y, so 4 comma 17. There's my first part of my answer. And for the second one, we plug it in just like we did before. Y equals 3 times negative 1 plus 5, negative 3 plus 5. Y is equal to, let me see. Yeah, let's make sure here. Yep, 2. So we have our point as negative 1 comma 2. And let me just verify I did this correctly. Negative 4 plus 1. Good. So negative 1, negative 3, 5. Nope, that looks good. So those are my 2 points right there. All right, for the second one, it says to solve it by elimination. So when using elimination here, we have to eliminate a variable. So for me, x squared, 3, and negative 10 don't go away, but the 4 and the negative 1 do. So to eliminate, I'm going to go for the y's. I'm going to eliminate those. I'm going to multiply the bottom one by positive 4. So the top one, we're going to rewrite it. Negative 10x squared plus 4y is equal to 10. The bottom one, 4 times 3x squared is 12x squared. And then 4 times negative y is minus 4y. And then 4 times 2 is 8. And here, negative 10x squared plus 12x squared is 2x squared. And you can see the y's do cancel. And then 10 plus 8 is 18. What I can do right here is to simplify it, I can divide both sides by 2. And that's going to give me x squared is equal to 9. Now at this point here, you could take the square root and solve it through like that, but since we've been working on factoring, I'll stick with that. So I'm going to subtract the 9 over to the same side. Then I'm going to go to the x method. And it is one of those special cases. So a is 1, b is 0 because there's no bx, and then c is negative 9. So it's going to be 3 minus 3 is 0, and 3 times negative 3 is negative 9. So add to here and multiply. So then it's going to be x plus 3 times x minus 3 is equal to 0. If I set each one equal to 0 and solve it, then I get x equals negative 3 and x equals positive 3. So I'm going to draw a line here once again so my work doesn't get confused over here. So x equals negative 3 and x is equal to 3. Now I'm going to substitute it in. Now both of them are not very nice, so I'll use the second one. 3 times negative 3 squared minus y is equal to 2. 3 times negative 3 squared is 9, minus y equals 2. 3 times 9 is 27. minus y is equal to 2, and then we're going to go ahead and subtract 27 from both sides, and we get negative y is equal to negative 25. Last, we divide by negative 1, and y is equal to 25, so my coordinate is negative 3, positive 25. And to verify this answer, I could just type it into Desmos to make sure I am doing it correctly. So for this one over here, we're going to do the same thing. 3 times 3 squared minus y is equal to 2. 3 times 3 squared is 9, minus y is equal to 2. 27 minus y is equal to 2. So notice the process, and the work is going to be the same here because of the square. So now we have negative y is equal to negative 25. Divide by negative 1, and y is equal to 25. So my order pair here is 3, 25. And once again, just for this one, I'm going to verify it in Desmos so you can see that the work does work out. Hopefully. So there's my work to get the answer. Now if I want to check my answers, this is what I would do. Go to Desmos, type it in. All right, and then I go to my next one. X squared minus y. All right, and we can see we have two intersections. One is right here at negative 3, positive 25, and the other one is at 325. So we can see that our answers both work out correctly. All right, for the next one, it says match the inequality with its graph here. Honestly, with this problems here, I would just type them into Desmos and then get my answers pretty quickly here. So let me show you what I would do with this one. So just by reasoning, honestly, these two have no equal bar, so they're going to be dashed. And this is the only solid one, just by looking at that. So the only solid one is C. So without even really doing anything mathematical, just by knowing the solid versus dashed line, I can know this one's C. Now for A and B, once again, I really don't need to do anything as well because this is negative, which means it's facing down. This A is positive, which is facing up. So I can know this is C, A, and this is B. But just to show you what you can do, if you have forgotten a little bit of this, you can type it into Desmos. So y is less than or equal to x squared plus 4x plus 3. And we can see right here that that does match up with letter C. You can see there on the outside facing up. Okay, so that's how you could do numbers 3, 4, and 5. All right, on to number 6, solve the inequality by hand. All right, so for this one, what we are going to do is we're going to, first, we need to make sure that it's set equal to 0. So we're going to add the 6 over. So let's go with x squared plus 5x plus 6 is less than or equal to 0. Standard form, no greatest common factor, not a special case. We're going to go to the x method. So a is 1, so divide by 1. B is 5, and a times c, so 1 times 6 is 6. So my factors that add to 5 and multiply to 6 are going to be 3 and 2. So that's going to give me x plus 3 and x plus 2 is equal to 0. So now I set each one of these factors equal to 0, and I solve. So x is equal to negative 3, and x is equal to negative 2. Now from class, to figure out the inequality, we drew a number line. We placed our solutions on there, so negative 3 and negative 2. And that's an equal bar, so that's going to be a closed circle. And we're going to test the point. So we like to test the point 0. And for us, 0 is on the outside here. So what that means is if 0 works on the outside, if it's true, then the outsides are going to be true. It's going to be split apart. If I test the 0 and it's not true, then the point in between is true, and it's going to be a between statement. So let's go ahead and test it out. So we're going to use this one. So 0 squared is 0. 5 times 0 is 0. Plus 6 is less than or equal to 0. So is 6 less than or equal to 0? That is false. So therefore, this is false and this is false. And the true falls in between these two lines, which means it is a between statement. So we get that negative 3 is less than or equal to x, which is less than or equal to negative 2 because the inequality is equal to, and my circles are closed. All right, let's go ahead and take a look at the next problem. For the next one, it's already set equal to 0. It's in standard form. there is no GCF. Now this is one of those special cases, but let's go ahead and do the X method still. So your B value is negative 20, your A value you're dividing by is 4, and you have to multiply A times C and you get 36. So my factors for this are going to be negative 2 and negative 18. Now negative 18 over 4 reduces to negative 9 halves, and negative 2 over 4 reduces to negative 1 half. So this one we can write as 2x minus 1. This one as 2x minus 9 is equal to 0. Now we set each one equal to 0. First I'm going to add one right here. And then divide by 2. And x is first equal to 1 half. And then for this one, same process, add 9. So 2x is equal to 9. Divide by 2. X equals 9 halves. So now we go to our number line. 1 half is smaller, and that's going to be an open circle. And 9 halves is like 4.5, so over here. And once again, 0 falls on the outside, so I'm going to test it right here. So 4 times 0 squared is 0, negative 20 times 0 is 0, plus 9 is less than 0. Is 9 less than 0? That is false. So it appears once again, we do have a between statement. So that's going to be 1 half is less than x, which is less than 9 halves. All right, let's keep going here. Number 8. Number 8 says, analyze a situation involving a quadratic functions, formulate a quadratic equation, and then solve the problem. All right, so the length of a rectangle is 5 feet more than twice the width. Write the function of the area in terms of the width. Okay, so we know the width is w. And so this one, remember, length is 5 feet more than is plus twice the width. And the word than is a turnaround word, so instead of writing 5 plus 2w, we write 2w plus 5. Now to find the area, if you recall, we just multiplied length times width, so w times 2w plus 5. And then from here, we're going to distribute it. So w times 2w is 2w squared. And then w times 5 is 5w. Now both equations are acceptable because they are both area in terms of width, but this is the one you need to solve, and this one would be acceptable as well. All right, from here it says, if the area of the rectangle is 18 feet squared, find the dimensions. So what we're going to do is we're going to substitute 18 feet for a of w. So we have 2w squared plus 5w is equal to 18. And I'm going to go ahead and subtract that 18 over. And now it's in standard form. And now let's just identify this one, make sure we know what a is 2, b is 5, and c is negative 18. So I'm going to do the x method here. 5 on the top, divide by a, and 2 times negative 18 is negative 36. So my factors are going to be 9 minus 4. This does reduce to negative 2. So I have 2w plus 9 and w minus 2. Now we're going to set each one of these equal to 0. So for the first one, w equals negative 9 halves, and the second one, w equals to 2. We're going to pick the positive width, so 2 feet. To find the length here, we're going to do length equals 2 times w plus 5. So I'm using that formula right there, 2w plus 5. So 2 times 2 is 4, 4 plus 5 is 9 feet. And then for the perimeter, 2l plus 2w, so 2, 4, 9, 9, 18. So 18 plus 4 is 22 feet. All right, on to the next page. So for this one here, this is based on the vertical motion. So the question says, the vertical motion can be modeled by this formula, where v sub 0 is the initial upward velocity, t is time, and h sub 0 is the initial height, and h is the height of the object. Use this formula to model the situation given in questions 13 and 14. Okay, so it's really talking about question number 9. So a twirler throws a baton with an initial upward velocity of 15 meters per second. So the initial upward velocity right here is going to be v sub 0, and an initial height of 1.3 meters, so that's h sub 0. So when I write this equation, we start with h equals negative 5t squared plus the initial velocity of 15t plus the initial height of 1.3. And then these questions now, I'm going to answer them, but before I do that, I'm going to go ahead and type this equation into Desmos. And this will, I'm going to solve all of this in Desmos, so let's take a look here. So we have y equals negative 5x squared plus 15x plus 1.3. All right, so here is our graph. I'm going to zoom here so we can see it. All right, first question says, all right, there we go. The first question says, when will the baton hit the ground? So that's going to be your x-intercept. So right here at 3.084. So we're going to write 3.084 seconds. That's when the baton will hit the ground. Next question says, calculate the height after 2 seconds. So it says to calculate the height of 2 seconds is time. So right here, x is time. So we're going to say x equals 2. Then we're going to find the height right there where they intersect. And it says 2 seconds, 11.3 meters. For my next one, it says, at what times will the baton be 8 meters above the ground? So when they give us 8 meters, what they're actually giving us is y equals. So we're going to say y is equal to 8. And it says at what time. So there's 2 times where it's above, or it's 8 meters above the ground. So the first one is right here at 0.546 seconds. And the second one is at 2.454. And this is both units of time. And last, it asks, what is a reasonable domain and range? So for the domain, this x-intercept goes negative, but that's not a part of the situation. So it starts at 0, and it stops at 3.084. So bracket 0, comma 3.084. That is the domain. And for the range, we can see the lowest value is y is 0, and the maximum is 12.55. So 0, comma 12.55. So there's your reasonable domain and range for this situation. All right, for my next one, it says to find the dimensions and maximum area of a rectangle if its perimeter is 40 centimeters, use a calculator. Okay, so let's go ahead and say that, let's change the color. Let's say that x is the length and y is the width. So I'm going to go ahead and draw a little quick rectangle here. So we have x, x, y, and y. All right, so to find the perimeter, it's 2 x's plus 2 y's is going to be equal to 40. We're going to solve this for y, so we're going to first subtract 2x from both sides. So 2y is equal to 40 minus 2x. Then divide all terms by 2, and we get y equals 20 minus x. Then our second equation is the maximum area. So area is length times width. In this case, it's x times y. And since we need a quadratic function, what we're going to do is we're going to substitute 20 minus x in for this y, which is going to give us a equals x times 20 minus x, which is our second equation that we need. And this is the one that's going to go into Desmos because this is a quadratic function because x times x is x squared. All right, so we need to find the vertex. And after we find the vertex, we'll interpret what we need. Okay, so let's take a look here. Keep that there. All right, so my equation is y equals x times 20 minus x. We have that there, so we're going to find our vertex. All right, so vertex right here, and we can see that's at 10, 100. So in class, we've talked about it, so we know that the length is the first x value, that's 10, and our units is centimeters. Our width is not this one. Our max area is that one, 100 centimeters squared. And to figure out this width, we can plug it in here. 20 minus 10 is 10. Or we could have taken 100 and divided by 10 and got 10 as well. So those are my answers to the first one. All right, let's take a look at the second one here. it says to find two numbers whose sum is 22 and whose product is a maximum. So we'll say x is going to be the first number and y is the second number. All right, so the sum is 22, so x plus y is equal to 22. And this one's pretty easy. We just subtract the x from both sides, and y equals 22 minus x. For my second one, it says whose product is a maximum. So that means we're gonna multiply them. So we'll say m for maximum equals x times y. Just like the previous one, we're gonna substitute this for this. This is the one that's gonna go into Desmos, and then we're gonna find our vertex. So notice it's just very similar to the previous one, except that changes 22. Okay, so we go back to our vertex, which is at 11, 121. So once again, this is going to represent our first number. So x, the first number, is 11. We don't know the second one yet, but we know the third, the max product, is going to be 121. And you can either divide these two or plug it in here. So 22 minus 11 is 11, and which makes sense because 11 times 11 is 121. And notice I didn't put units because there were none. You could put u for units if you wanted, and units squared, but for here it's talking about numbers, so that's not necessary. All right, we're on to number 12 now. Number 12 says Erica has 120 feet of fence to make a rectangular pen for llamas. If a shed is used as one side of the pen, what would be the length and width for maximum area? So let's go ahead and define this as x equals the length, y equals the width. So let's draw a representation of this. So this top part is going to be the shed. We'll call this x and this y. So from our perimeter, 2x plus 1y is equal to 120 feet of fence. This one here, we can subtract the 2x from both sides, and we get y is equal to 120 minus 2x. Now for our second equation, it says, how do we find the maximum area? So a is equal to x times y. We substitute this in for y. This is going to give us our quadratic function. And just like before, we're now going to plug this equation into Desmos and find our vertex. Alright, so let's take a look here. So we have y equals x times 120 minus x times 120 minus 2x. Oops, and I put there we go. All right, let's go ahead and see what this looks like. So we need to find that vertex. So there it is right there. And it's 30, 1800. So for our length, that's the x value, which we identified. So our length is 30 feet. For our width, we don't quite know that yet. We do know that our max area is 1800 feet squared. And at this point here, it's up to you. You can divide them or plug it into here. You can say, if you wanted to, you could say y equals 120 minus 2 times 30. So 120 minus 60 is 60 feet. And like before, you could have said 1800 divided by 30 is 60 feet as well. All right, on to number 13. For number 13, it says a taxi service operates between two airports transporting passengers, 150 passengers a day. The charge is $12. The owner estimates that 3 passengers will be lost for each 50-cent increase in the fare. What charge would be most profitable for the service? Use your calculator. Okay, so first we're gonna have to come up with these equations here. So let's say x and y. X will be the number of times the fare is increased, and y is going to be your revenue. So first we know that y equals, we have 150 passengers times $12. So that's our current revenue. Now, to maximize this or make it most profitable, they go on to say that the owner estimates that 3 passengers will be lost. So if you lose 3 passengers, that means it's going to be, this is passengers, so 150 minus 3. Now, how many times? It's going to be the number of times you increase the fare, which is X. And then the price is currently $12, and we're going to increase it by 50 cents so many times, which is X as well. So then from here, we know that the passengers, so we want the equation, which is going to be right here. We're going to type this equation into Desmos. We're going to want the number of passengers. Oh, that was that, sorry. So the number of passengers and the optimal price and the max revenue. All right, so let's go ahead and plug this equation into our calculator, and then we're going to figure out what X and Y are. All right, so for our first one here, let's go ahead and just start doing this over. Okay, so we have that equation right there. We're going to go ahead and plug it in. So Y equals parentheses 150 minus 3X and 12 plus 0.5X. All right, so there is our line, our graph. Let's just keep going. There's our vertex. And that's what we're looking for. So 13, comma 2053.5. So vertex is 13, comma 2053.5. All right, so let's talk about these numbers now. We know that the max revenue is represented by here, so our max revenue would be $2,053.50. This 13 is the number of times that we're going to increase the price. Okay, so for that, we're going to do, for the number of passengers, 150 minus 3 times 13. And for the price, it's going to be 12 plus 0.50 times 13. Let's see what these answers come out to be. So for the first one, I'm just going to type it in here. So 150 minus 3 times 13, which means I'll have 111 passengers. And for the optimal price, that's going to be 12 plus 0.5 times 13, which means I have to charge $18.50. $18.50. And then if we can multiply those, 111 times 18.5. Nope, I forgot the 18. It's going to give us the actual answer we're looking for there. All right, so we're down to the last one here. And let me go ahead and show you this. So number 14, it says use the following formula to solve h of t equals negative 16t squared plus v sub 0t plus h sub 0. So a missile is fired upward from the top of a tower at a velocity of 2,000 feet per second. So this is going to be our v sub 0. The tower is 150 feet high. That's going to be our initial height. A spy plane is cruising at an altitude of 68,000 feet. Will the missile be able to reach the spy plane? Justify your answer, use a calculator. So first, let's come up with the equation. Negative 16t squared plus our initial upward vertical velocity of 2,000 feet per second, so 2,000 t plus our initial height of 150. So now we're going to find our vertex, and that's going to give us our maximum height here. So let's go ahead and plug that into Desmos real quick and get that answer here. So we have y equals negative 16x squared plus 2,000x plus 150. All right, from here, we're going to go find our vertex, which is very high up. There it is. So just click there. There's the vertex, and you can see that the vertex is at 62,650 feet. So my max height for this is going to be 62,650 feet. So the question says, will the missile be able to reach the spy plane? Just for answers. Well, the spy plane is 68,000 feet. The projectile will only reach 62,650 feet. So I'm going to say no. The projectile will not reach the spy plane. And obviously we can see that it's a big margin of difference there. All right, so that completes the review.